Hi and welcome to another Clear Sky Explainer video. In this video we will have a look at jet thrust. We often hear the phrase, for every action there's an equal and opposite reaction. This, my friends, is the essence of Sir Isaac Newton's third law of motion, and it's the fundamental principle behind how jet engines propel aircraft through the sky. Imagine a balloon filled with air suddenly released. The air rushes out the back, and in response the balloon darts forward. This is a simple demonstration of Newton's third law in action. Jet engines operate on the same principle, but on a much grander scale. Instead of air, they expel a continuous stream of hot expanding gases. This occurs when air is drawn into the engine, compressed, mixed with fuel, and ignited. The resulting combustion produces a powerful blast of exhaust gases. This ejection of high-velocity exhaust gases out the back of the engine creates a thrust force in the opposite direction, forward, propelling the aircraft forward. The greater the mass of gases expelled and the faster they're ejected, the more thrust the engine produces. It's as simple and as elegant as that. Now let's consider how thrust changes with speed, a concept that might seem a little counterintuitive at first. You might think that as an aircraft accelerates and its speed increases, the thrust would naturally increase as well. However, the relationship between thrust and velocity is a bit more complex. In the early stages of a flight, during takeoff and initial climb, the engine needs to produce the maximum required thrust to overcome the aircraft's inertia and lift it off the ground. At this point, the speed is relatively low. As the aircraft gains speed, the thrust required to maintain that speed actually decreases slightly. This is because the increasing velocity of the aircraft means that the incoming airflow into the engine is already moving faster, providing some momentum. Think of a swimmer pushing off the pool wall. The initial push is the strongest, propelling them forward. As they glide through the water, they need less force to maintain their speed. Moving our attention upward, let's explore how altitude affects thrust. As an aircraft climbs higher into the atmosphere, the air density decreases. This thinner air has fewer molecules packed into the same volume, which might seem like a good thing, but it actually poses a challenge for jet engines. Remember, thrust is generated by accelerating a mass of air. With less dense air at higher altitudes, the engine takes in less air per unit of time. This reduction in air mass flow results in a decrease in thrust. Imagine trying to inflate a balloon at sea level versus on top of a mountain. The balloon would inflate much faster at sea level because there's more air to work with. The same principle applies to jet engines. Feeling the heat. Temperature and its impact on thrust. Temperature also plays a crucial role in the performance of a jet engine. As we know, heat causes air to expand. Therefore, on a hot day, the air density is lower, similar to the conditions at higher altitudes. This thinner, warmer air means that the engine intakes less air mass, resulting in reduced thrust. Conversely, on a cold day, the denser air allows for greater air mass flow, leading to increased thrust. Picture a cold winter day when you can see your breath. The air feels heavier, denser. Now imagine that same breath on a scorching summer day. It dissipates quickly in the thinner air. This difference in air density, influenced by temperature, has a direct impact on jet engine performance. Fuel for thought, consumption in different flight conditions. Now, let's talk about everyone's favorite topic, fuel consumption. As you might have guessed, fuel consumption is directly related to thrust and engine performance. When an aircraft is climbing to cruising altitude, the engines are working harder to produce thrust in the thinner air, requiring more fuel. Similarly, during hot weather operations, the engines need to work harder to compensate for the reduced air density, leading to increased fuel burn. At higher altitudes, where the air is thinner, the aircraft can travel faster at the same thrust setting, which can improve fuel efficiency. However, this needs to be balanced against the increased fuel consumption during the climb to that altitude. In conclusion, jet thrust is a fascinating interplay of physics and engineering. Understanding the factors that influence thrust, such as speed, altitude, and temperature, is crucial for optimizing aircraft performance and fuel efficiency. It's a testament to human ingenuity that we've harnessed the power of Newton's third law to soar through the skies. Thanks for watching. Don't forget to like and subscribe.